Hello guys, welcome to my channel. Today we will discuss about one of the most important system on board, that is the refrigeration system. Before starting the refrigeration system, let's identify the equipment required for refrigeration system. Refrigeration system that works on vapor compression cycle has following basic component. First is the compressor. Next is the condenser. Next is the solenoid valve. Next is the expansion valve. Next is the evaporator. And the last one is the refrigeration fluid. We know that the saturation temperature, it is the temperature at which fluid boils or condenses, varies with the pressure. So, for obtaining the desired temperature, the refrigerant fluid is pressurized and passes through the evaporator to reduce temperature of the chamber. The refrigerant fluid is passed through the compressor. The compressor job is to raise the pressure of the vaporized refrigerant. This high pressure refrigerant helps the refrigerant fluid to pump around the system. While increasing the pressure, the temperature of the refrigerant also increases. Now the refrigerant is in the state of superheat with high pressure vapor with temperature 90 degrees Celsius and pressure 11.92 bar. This superheat refrigerant with high pressure goes to the condenser. In the condenser, the refrigerant is subcooled by circulating seawater to the temperature below its saturation temperature. In this, the refrigerant transfer heat to the seawater and vapor will get condensed to liquid with a decrease in the temperature. Now, the refrigerant is in the state of subcooled liquid, that is low temperature, that is 25 degrees Celsius, and high pressure, that is 11.92 bar. Now, the refrigerant fluid is passed through the filter dryer. The purpose of the filter dryer is to ensure that the refrigerant system stays clean and dry. So, this filter dryer will remove contaminant including moisture, dirt, acids. The subcooled liquid then further goes to the expansion valve. The expansion valve is the throttling device through which refrigerant flow from the high pressure side to the low pressure side. Due to pressure drop, boiling point of the refrigerant comes down and it start evaporating. The latent heat came from itself and its temperature drop, that is to about minus 35 degree and 1.2 bar. In the diagram you will see a solenoid valve. The role of the solenoid is to move the refrigerant to all the necessary parts of the refrigeration cycle. This includes from the compressor to the condenser. When no cooling is needed, the solenoid valve is closed, directing refrigerant to the suction valve instead of the condenser. The refrigerant then enters the evaporator coil, where the heat exchange will take place. Here, the refrigerant has the temperature lower than that of the surrounding temperature. So, this full cycle is known as vapor compression cycle and is repeated again and again until the desired temperature is not acquired. So, the refrigeration cycle consists of four important components, that is the compressor, condenser. In the refrigeration cycle, the refrigerant fluid will be first compressed by the compressor, and at the output we will get high pressure and high temperature gas. Then it will go to condenser, where the temperature of the refrigerant fluid is reduced by the mean of heat exchange with the water. So at the output we will get high pressure and low temperature gas. Next it will go to expansion valve, which consists of orifice where the pressure will be reduced. So at the output we will get low pressure and low temperature liquid and vapor. Next it will go to evaporator where heat exchange will take place. So at the output we will get low pressure and high temperature gas. This process will be repeated until desired temperature is not achieved. So now let's study each components of compression cycle in detail. Compression is the first step in the refrigeration cycle, and the compressor is the piece of equipment that increases the pressure of the working gas. Refrigerant enters the compressor as low pressure, low temperature gas and leave the compressor as a high pressure, high temperature gas. The compressor used in refrigeration system is the belt driven type, in which the compressor is driven by motor through belt. Now comes the condenser. The condenser removes heat from the hot refrigerant vapor gas until it condensates into a saturated liquid state. After condensing, the refrigerant is a high pressure, low temperature liquid, at which point it routes the loop's expansion device. The heat exchange is done in condenser by the water. The solenoid valves are control units which in normal condition block the supply of the refrigerant to the evaporator coil, as you can see in the diagram. When this solenoid valve is electrically energized, it will allow fluid flow. The actuator takes the form of electromagnet. When energized, a magnetic field builds up which pulls a plunger or pivoted armature against the action of the spring. This will cause the flow of refrigerant fluid in the system. Now, next one is one of the most important component in the refrigeration system, that is the expansion valve. The thermal expansion valve or thermostatic expansion valve is a component in air conditioning system that controls the amount of refrigerant released into the evaporator and is intended to regulate the superheat of the refrigerant that flow out of the evaporator to a steady value. The basic construction of TUV consists the flexible diaphragm that actuate the poppet valve. An increasing pressure in the sensing bulb will press down the poppet and open the valve further. There is also an adjustable spring providing a closing force on the valve which control the superheat. The sensing bulb is positioned near the end of the evaporator and ensures enough refrigerant flow to chill the whole evaporator, but not so much that the liquid reaches the sensing position. There are some safety devices fitted in the refrigeration system of ships. Low pressure cutout or LP cutout. This is a compressor safety device that cut off the compressor when there is pressure drop in the suction pipe. This is set at the pressure corresponding to 5 degrees Celsius below the lowest expected evaporating gauge reading. High pressure cutout or HP cutout. This is also a compressor safety device in which high pressure cutout activates and trips the compressor when the discharge size pressure increases above the limit value, set at the pressure corresponding to 5 degrees Celsius above the highest expected condensing gauge reading. Oil differential cutout, also known as lube oil low pressure cutout. This safety is again for the compressor, as it is the only machinery in the circuit having rotational part which require continuous lubrication. Oil pressure usually set at 2 bar above the crankcase pressure. When this pressure increases, it will activate trip to safeguard compressor. Relief valve. It is fitted on the condenser refrigerant line and is used to avoid damage to the condenser if there is high pressure in the discharge line. Solenoid valve. It is fitted in the common or main line after the condenser discharge. It closes when the compressor stop or trip to avoid overflow of refrigerant into evaporator. It is used to prevent liquid from being entered into compressor when the plant is standstill, especially in a large plant.